Paper 1R, June 2016, question 2. So I'm going to struggle with this one because it's got the word astronomical in it, which I do not like. So every time I get this wrong, you are not allowed to giggle. So starting off with the first bit, one astronomical object smaller than the Earth is. You have got lots and lots of choices here. You can go for any of the planets that are smaller than the Earth. So that can be Mercury, Venus, or Mars. You can have any of the other things floating around in space. I'm going to go for an asteroid. They live in a belt between Mars and Jupiter. You could also go for satellites, meteors, a moon, comets. All of these will be smaller than the Earth. For two astronomical objects larger than the Earth, again, easiest thing is to go for one of the bigger gas giant planets. So you could have Jupiter, Saturn, Uranus, or Neptune. You could go for some kind of bigger astronomical object, so something like a galaxy or a solar system or a star. Any of those is absolutely fine. And the Milky Way is the name given to our galaxy. So no obvious chocolate-based jokes there. Okay, next bit. State the name of the force that causes the comet to orbit the sun. So be careful with your language here. The best answer to go for is gravitational force. Absolutely get the marks for that. Weight would be okay as well, just about. But be careful, you can't just have the word gravity. Okay, because that's not a force. Right, at which of the points shown is the force on the comet greatest? So we know that gravity gets weaker the further away you are from the source of gravity. So on this picture, this part of the orbit is closest to the sun. This part of the orbit is furthest away. So the force on the comet will be greatest here at B. Draw an arrow at point D to show the direction of the force acting on the comet. So because it is gravitational force, when things are in an orbit, it's in this case, it's not circular, it's elliptical, but it's the same kind of idea. Wherever you are in that orbit or on that path, the force will be acting towards, in this case, the source of the gravity. Okay, so reacting towards the sun. If it was a circle, then it would always be acting towards the center. So slightly more complicated here. You're always acting towards this point here because that's not the center of the orbit, but the focus of the orbit. And part 4, at which of the points shown does the comet have the greatest kinetic energy? So this is going to be when it is moving fastest. It will have the greatest kinetic energy. So during this part of the orbit, you could see that the comet will be accelerating as it gets closer to the sun. But then during this part of the orbit, it will be decelerating as it moves away from the sun, but the gravitational force is kind of pulling it backwards. So here where it's accelerating, it's pulling it forwards in the same direction as it's moving. So the point where it's going to be moving the fastest, so the point where it's got the most kinetic energy, is B again.